linear interpolation and extrapolation. I'm Mr. Hyper, and I'm taking you through numerical methods that is applied mathematics, and we are going to look at linear interpolation and extrapolation. We need to know that this area deals with the computation of values that lie within a given range, and we may be interested in finding values that lie within between, or we can find values that lie outside the range of the given values. Now, here, if we consider a function, let's begin with interpolation. With the linear interpolation, it means that we are linear from a line. It means that these values, once plotted, if you plot the values, they produce a straight line. And you know that the gradient of the straight line is constant. Now, if we say linear interpolation, we are dealing with getting values that lie between others. Okay. For example, if you consider a function y equals to f of x, if I consider a function y equals to f of x, and maybe I sample some values, when x is x1, y will be y1, when x is x2, y will be y2, when x is x3, y will be y3, etc. When it is xn, etc., it will be yn. Now, if I'm having these values, plotting these values, okay, if we represent this data on the graph, we are going to come up with something like this. This is x, and this is y, or f of x, but we say that it must produce a straight line through the origin, and we are going to have at different, because I'm not on scale, that's why I've first drawn a line, but we shall have x1, y1 here, and here we can have our values of b as maybe x0, y0, and you can have values of c as x2, y2. Now, looking at this, we can correspond this one with x0. You can correspond this one with x1, and you can correspond this one with x2, and correspond this one with y0, and correspond this one with y1, and then y2. If you're having this, we are saying that the graph is linear and the straight line. If we consider y is equal to fx, then as the equation of this straight line, if y is equal to fx is the equation of this straight line, it would mean that gradient of SC is equal to gradient of AB, being a straight line. So gradient of SC is how we get gradient of SC. We shall get f of x2, because we say that y is f of x. So it will be y2 minus y1, meaning it will be f of x2 minus f of x1 divided by x2 minus x1. So that is our gradient. Then gradient of AB going to be changing y, AB, so we shall have y0 minus y1. So it is going to be f of x0 minus f of x1. Why am I saying f of x0? Because y is already f of x, meaning if I have y0, it is f of x0. So divided by x0 minus x1. So we shall have x0 minus x1. But remember, for a straight line, gradients remain constant, implying that the gradient of AC is the same as the gradient of AB. Right, so now this one will take us to the fact that the gradient of SC is f of x2 minus f of x1 over x2 minus x1, which is equal to f of x0 minus f of x1 out of x0 minus x1. So if we are to look for the value that lies between two successive values of maybe x1 and x2, it means that we are either looking for x0 or f of x0. If we need a value that lies between x2 and x1, then it means that that value is either x0 or f of x0. You can get the value of x, you can get the value of y. So that is what we call linear interpolation, implying that you can get the value of x0 by making x0 the subject. And if you make x0 the subject, you're going to have x0, okay? You're going to have x0 equaling to x1 plus, here you do some kind of algebra, f of x0 minus f of x1, then x2 minus x1 out of everything is f of x2 minus f of x1. But there is nowhere you're going to prove this, but instead we are going to apply it. You can reserve the proving in the near future for the near future. But we are going to see how we apply extrapolation, rather interpolation, and we get the values that are required. Then a brief also on extrapolation, linear extrapolation. When we say extrapolate a point, it means that if the point is here, we are extending it away. Now, when we say linear extrapolation, okay, it deals with the computation of values lying outside the given data. Outside the given data. Okay, so now, if we talk about the values that lie outside the given data, if we still consider the values, or if we consider the same function well of y is equals to fx, this one would mean that if you have x and y here, if you have values like x1, y1, x2, y2, x3, y3, up to xn, up to yn. So if you have all these values here, and then you need the values that lie outside. Now we are looking for, we shall be looking at the values that lie outside. But since I need the values that lie outside, maybe let me call this one x0 by removing this, and maybe I call this one y0. I need how to get this x0 or y0. Okay. Now, by plotting some graph here, still a straight line is going to be produced and through the origin. So I have my first point there. I have done this because I can make mistakes as I do without rulers and not and others. So we have x1 here, we have x2 here, we have x0, we have y1 here, we have y2 here, we have y0. Okay, so now here you can really see that our point A is x1, y1, and our point B is x2, y2, and our point C is x0, y0. Now, looking at this, as we saw earlier, okay, as we saw earlier, still the gradient of AB is going to be equal to gradient of AC. So the gradient of AB is equal to the gradient of AC. So now looking at this, gradient of AB is going to be y2, which is f of x2, minus y1, which is f of x1, over x2 minus x1. That is a change in y, change in x. Then is equals to gradient of AC, y0 minus y1. So it is f of x0 minus f of x1 divided by x0 minus x1. So yeah, by making x0 the subject, it will be, actually it is x0 minus, this is it, x2, you're looking at AC. No, gradient of AB, for this case, gradient of AB will be going to gradient of BC, sorry, BC will be equal to the gradient of BC. So that here we have x2 and here we have also x0 minus x2. Gradient of AB is equal to gradient of BC. So now looking at this, it will mean that your x0 minus x2 is the same as x0 minus f of x2, but this is multiplied by x2. You try making it the subject of the formula, and then you see f of x2 minus f of x1. So if you make x0 the subject, x0 now will be x2 plus f of x0 minus f of x2 this is f of x0 minus f of x2. Then everything we are multiplying x2 minus x1 out of f of x2 minus f of x1. Okay, so now looking at this, looking at that, we are going to have a point where we are going to discuss some of the examples and we try getting the values required. So let's look at examples. All this has been an introduction. Show you that when they say interpolation, you're getting the values within between. Extrapolation, the values that lie outside a given data. So examples, given number one, example number one, given the information in the table below. We are having x, then f of x. When x is 0.9, we have 1.0, 1.1, 1.2. Zero 0.260, 0.242, 0.218, 0.192. So using linear interpolation. However, they may not tell you this. Using linear interpolation, find Roman 1 value of f of 1.04 to value of x corresponding to f of x is equals to 0.25. So it's a matter of being too smart, and then you see where the point wanted, where it lies. So this is the easiest thing that I can tell you about. Interesting. Now, when they say using linear interpolation, find the value of f of this, meaning if they say f of, now this is the value of x, so they need f. F of 1.04, meaning if it is f of x, this is it, the x value. So this, we are given x, they need the value of f. So you are going to locate where 1.04 lies in your table. 1.04, 1.04, this is 1.0, this is 1.1, meaning 1.04 lies between 1.0 and 1.1. So we just need to extract this table, and then we place the value that we want. So extract, for part 1, we are going to extract the value where it, the table where it lies. So we shall have x and f of x. So we shall pick 1.0 and its corresponding value is 0.242. Okay, then our value lies between 1.0 and 1.1. So here is 1.1 and here is 0.218. So our value is in between. So we have 1.04, but we don't know this value. Maybe I can call it y. So that is what we have extracted. But using the gradient approach, if this is my A, B, C, gradient, we can say that for that case, gradient of AB, gradient of AB is equals to gradient of what? Gradient of SC. Good. Gradient of AB is equals to gradient of SC. Interpolation. Now, gradient of AB would be change in y over change in x. So these are y values. The function is a y. F of x is equals to y. So this is y. So we shall have y minus this over this minus this. That is for AB. For AB would be y minus 0.242 out of change in x, which is 1.04 minus 1.0. This is equal to gradient of SC. Gradient of SC is going to be equal to 0.218 minus 0.242, because we get change in y, which is 0.218 minus this, over change in x, which is 1.1 minus 1.0. So over 1.1 minus 1.0. So this is going to be y minus 0.242 divided by 1.04 minus 1. This is the same as 0.04 is equal to, this is 1.1 minus 1, that's 0.1. Then this one, the whole thing will give us negative 0.24. And then we make y the subject. So if you cross multiply, you're going to have your y minus 0.242 is equals to, when you multiply these two, you're going to get negative 0.0096. So it implies that you're going to add it this side. So your y is going to be 0.0096 negative, but plus 0.242. And you're going to get your y value as 0.232. Did they tell us where to correct? Since in the table they are given in 3 decimal places, you can also stop it there. 3 decimal places. As simple as that. Interpolation. And indeed, when you bring this value, here, you find it suiting. And now another question. They need us to excuse me, dear members. Okay, let's take it that way. Let's take it that way because that is what we are given. Don't change. We don't need to change any question now. Then for part 2, they need the value of x corresponding to f of x as this. So now we are given f of x. So if we are given f of x, what do you do? Still, we are going to extract. We have x, we have y. They are saying corresponding to f of x as 0.25. X is 0.2, rather f of x is 0.25. But here we are having 0.26, and this is 0.24, meaning that 25 is in between, okay? In between here. So we shall have our x as 0.9, and its value is 0.260. Then our value is lying in between there, but they need the value of x corresponding to f of x as 0.25. Then the next one is 1.0 and then 0.242. Now, if you're given this, still by gradient approach, shall have gradient of A. Here we have BC. So it means that the gradient of AB is equal to gradient of AC. Okay? Gradient of AB is equals to gradient of AC. Let me do it from here. Now, gradient of AB, it will be 0.25, right? 0.25 minus 0.25 minus 0.260 over x minus 0.9 is equal to the one of AC. AC. So it will be 0.242, 0.242 minus 0.260 minus 0.260, everything divided by what is SC, so it is 1.0 minus 0.9. 1.0 minus 0.9. So you try and solve for the value of x, and you see what you will get. All right. Let me do some other one question. Let me do some other one question. And the question is, the distance covered by a certain body and time are shown in the table below. The distance covered by a certain body are shown in the table below. So we have distance and we have time here. Distance is in meters, time is in seconds. We have 0, we have 0. We have 5, 12, 10, 25, 15, 39, 20, 54. So this is what we are having as our table. Find a time when distance x is 12 meters. Find a time when distance is 12 meters, that is 1, 2. Find distance when time is equals to 45 seconds. This is what we are having. So looking at the table you're having, you need to look at where the value needed lies. Now, find a time when distance is 12. They have given us distance as 12. So go and check for where in distance where 12 lies. 12 is between 10 and 15. So we shall need this one here. So we shall extract this. So we shall extract distance, time. We shall extract 10, corresponding with 25. So they, and we also have 20, rather 15, 39. But we need, when distance is 12, we need the time. So that is what we are having. Now, by using gradient approach, still it's the same thing. By using gradient approach, if this is ABC, gradient of AB is equal to gradient of SC. Gradient of AB is equals to gradient of SC. Now, gradient of AB will be T, so we shall have T minus 25, T minus 25 out of 10 minus, out of 12 minus 10 is equals to SC. SC, it will be 39 minus 25 out of 15 minus 10. So this will be T minus 25 over 2 is equals to 39 minus 25. That is 6. No. 14 over 5. So this will be 5t minus 125 after cross multiplying and multiply 4 will be equaling to, and multiply 5, sorry, will be equaling to 28. So 5t is equals to 28 plus 125, and my t will divide by 5, so we shall have 28 plus 125 out of 5. And that's the time is going to be 30.6 seconds. Now, that is what we have. Then when they need when time is 45, when time is 45, where does 45 lie in time? It lies here, 39, 54. So we have 45 in between. So we shall extract this. So for Roman 2, the extract is, we have distance still, we have time. We have distance as 15, we have time as 39. In between, we have a value of distance, let me call it x, and then time is 45. Then the next value is 20 with a 54. So still by gradient approach, you can really see that AB, so it will be 45 minus 39 out of x minus 15 is equal to 54. It will be 54 minus 39 out of 20 minus 15. You can solve for the value of x, take all the steps. So it means that x minus 15, if you simplify this, you're going to get your x as 17. And you can really see that if you put here a 17 in between, we'll be having 15, 17, 20. Since it is a linear, you don't expect the falling down of the distance. So if you get distance like as 6, just know there is something wrong. So all the questions we've done have involved the interpolation, but let's do some other numbers. Let's do some other numbers, and maybe we see how best we can progress and see how best we can progress. I want everyone to try this out. It is for some examination paper given the table below of corresponding values of x and y. We have x, we have y, 0, 9.2, 8, 6.0, 12, 4.4, 20, 1.5. Use linear interpolation, very specific, use linear interpolation. So here you are going to use what exactly we have been looking at. Use linear interpolation to find Roman 1, y when x is 15, Roman 2, x when y is 5.0. So now here, you can use linear interpolation to find that using the approach that we have looked at. Now, as we progress with our questions, or as we progress with our examples, let me do another example that would be needed most in where we are going. And that example, they want us to use linear interpolation once, use linear interpolation once, find a better approximation of the root of the function f of x equals e power x minus 1 lying between x is equals to 1 and x is equals to 1.5. Collect to 3 decimal places. So if they give you such a question, they want you to use the linear interpolation once. Find the values of x, find the root lying between x is equals to 1 and x is equals to 1.5. Now, the solution of this question would be, because we are being given a function, so given f of x as e to the power x minus 2x minus 1, we shall first need to get the value where f of 1, we need to get f of 1. F of 1 will be e minus 2 minus 2. Actually, this was x. So it would be e minus 2, then minus 1. Okay. So the e is on the calculator. You can press it and you put the value. You find yourself having 0.282. Then you also get f of 1.5. If you get f of 1.5, it is going to be e to the power 1.5 minus 3 minus 1, rather minus 2 minus 1. Minus 2 minus 1. You have to be technical with the e you are using. There are two e's. There is an e which is in italics, and there is an e which is like this. When you use the e, the normal e, you don't put a power when you are when you're putting this. Just say e 1.5. Those are the normal e. E 1.5. It will give you e 1.5. It will give you the answer. But if you use the italic one, you have to put a power, then 1.5. Still, it will give you the same answer. We're going to come up with 0.4817. Now, we want to use linear interpolation to find a root. Okay, to find a root. Now, what you need to do, if we extract if we need a root, then it must be in the middle. And that root, the root exists at f when f is equals to 0, when the function is equals to 0. When you put this one to 0 and you perform some iterations or you perform some operations, you're going to get your root. So it occurs when the function is 0. So now here, if x is equals to 0, we get the root x. So meaning that here, when x was 1, our function was negative 0.282. And when it was 1.5, our function was 0.4817. So by having this info, we can get the value of x, and that would be our root. Remember, the root must lie between 1 and 1.5. So it shouldn't be above those. So by linear interpolation, the gradient of AB will be equal to the gradient of AC. So it will be 0 minus negative 0.282 over x minus 1 is equal to the gradient of AC, which would be 0.4817 minus negative 0.282 over 1.5 minus 1. Okay. So in solving this, you're going to come up with x. Take steps, solve, and see if your x is 1.18467. But since they need it in 3 decimal places, you conclude and say, hence the root, or the beta root is 1.185, correct to 3 decimal places. As simple as that. So that is it about linear interpolation. So let's do some question that involve extrapolation. Let me look for the question that involves extrapolation, and then you go practice. Here is one. Here is one. Here is a question. And the question says, the table below shows how y varies with x in an experiment at different points. So you're having x varying with y. You're having x varying with y. So in this case, we are having x as negative 1.0, y as negative 1.0 also. We're having x as negative 0.5 and y as negative 2.2. We're having x as negative 1.4 and here negative 3.7. So this is the table that we are having. Use, the question here was not direct, so a student is supposed to focus. Use linear interpolation or extrapolation find a y when x is 0.5 and b find x when y is equal to negative 4.5. So here they have not told you specifically that use this here or use this one here. Okay. So what we shall do, what we shall do is specifically like for this first one, when we are looking for y as x is 0.5, you draw your table when x is 0.5, meaning all these ones are small values. X is 0.5. So we shall have the value of x, we shall have y. But for x to be 0.5, it means that since all are negative, 0.5 is a bigger value, so it is outside the range. So, of course, there must be 3, meaning that we have to first bring the 0.5 here. So we are looking for y. Of course, now this one automatically, student will have known that this is linear extrapolation because we are outside now. 0.5 is a bigger value than all these, so it is outside. Now, the next values that are close to it. Now we shall take negative 1.0 and negative 0.5. You see, so because negative 1, you cannot bring negative 1.4, which is very small, yet you are looking for a bigger value. So you start with the lesser small, then you get to your big value. You are moving ascending order. So 1.0, negative 1.0 corresponds to negative 1.0 also. Negative 0.5 corresponds to negative 2.2. So if this is your A, B, C, for extrapolation, the gradient of SC is equal still to the gradient of AB. So gradient of SC is equals to gradient of AB. And you start SC, we have y minus negative 1, which will be y plus 1 out of 0.5 minus negative 1, which is 0.5 plus 1 is 1.0, of course, is equals to gradient of AB. It will be negative 2.2 minus negative 1, which will be plus 1.0 out of negative 0.5 minus negative 1, which is plus 1.0. So this one will give you y plus 1 over 1.5 down is equals to, it will be negative 1.2 out of 0.5. So by solving for this, it will be, you're going to get 0.5 into y plus 1 is equals to negative 1.5 times negative 2, and negative 1.2. So this will be 0.5y plus 0.5 is equals to negative 1.2 into 1.5. So you press a calculator, you're going to get your value of y. First bring 0.5 this side, then divide by 0.5 both sides. You're going to get your y as negative 4.6. That is what you will get. Okay. So now, from here, for this part 2, we are going to be looking for the value of x when y is negative 4.5. Now here, the extract can be, you need to first see where is the point needed located. Now for y, you can see the values are decreasing, negative 1, negative 2, negative 3. Now they need negative 4.5, meaning it is still outside because the values of y are decreasing. Okay. So what we do here, we shall extract, of course, we still have x and y. But since we need the value that is outside, when y is -4, rather -4.5, so now here we shall be looking for the value of x, meaning that we shall have other values of y that are coming while decreasing. So we shall need -3.7. Well, because one can take -1.0, -2.2, but we are looking for the value outside. So it is going to be, we are looking for x there. So if I have, we are looking for x there, but I can have y as my -2.2, and then here -0.5, and I can have -1.0 and -1.0. So this one can give you the value of x by extrapolation. If this is a, b, c, simply say that gradient of ab is equals to gradient of ac. I want you to solve that, and I see if you get the, and see if it can get if it can get you to the same thing. So you try locating it out by yourselves, and we see. There are very, very, very many questions which you can extrapolate or interpolate, and then see how best you can do it. I'm looking for one more example that I can do for you. I'm looking for one more example that I can do for you. And here it is. In the table below is an extract of part of log x to base 10. Okay, log x to base 10. So the table is given as x. We have x values, and we have log x to base 10. We have log x to base. No. We have log 10, log x to base 10. So here we have x. Okay. Now, here values were given, and the values which were given, we are given values of x as 80.00. We are given 80.20. We are given 80.50. We are given 80.80. Then here, we are given the values of logarithm, 1.9031, 1.9042, 1.9058, and 1.9074. So these are the values of logarithm that we are given. Now, the question is, use linear interpolation. They made it clear for you. Use linear interpolation. Estimate Roman 1 log base 10 of 80.759, and 2, you want to estimate the number whose logarithm is 1.9074. Okay, so that is what we are having. And part of the solution, they want you to get a number or estimate the number or to estimate the logarithm of this. Now we are given x. I think you can see they need the log. So you're going to check for where 80.75 lies. This is 80.5, 80.8, meaning 80.75 lies here. So we shall have an extract here. So we shall extract x and log 10 of x. But the first value we shall extract is 80.50. Then the value that we are looking for is this 80.759, right? And it is in between also 80.80. Now that is what we are looking for. So they need the logarithm. So here we shall put 1.9058. And here we don't know the value corresponding to that. We don't know the logarithm of this. Then here we have 1.9074. If this is your A, if this is your B, and this is your C, we shall say that gradient of AB is equal to gradient of AC. Gradient of AB is y minus this, so we shall have y minus 1.9058 over 80.759 minus 80.50. This should be equal to gradient of SC, which will be 1.9074 minus 1.9058 over 80.80 minus 80.50. So this is going to be y minus 1, going to be y minus 1.9058 over, when you take the difference here, the difference is just 0.259, and this is going to be equal to, when you take the difference here, it is 0.0016 over the difference here is 0.3. So when you cross multiply, it is going to be 0.3 into y minus 1.9058 is equals to, when you multiply these, you're going to get 0.004144. Okay, so this one is going to give you the value of y after solving. Put a step and solve for the value of y. So you're going to get the value of y as 1.9071, all right, 81333. But they want it in how many decimal places? Did they specify? No, they have not specified. Maybe you can appropriately put it 4 decimal places. So therefore, logarithm to 10 of 80.759 is 1.9072. And record to 4 decimal places like that. Then The other part, they want the value, the number whose logarithm is 1.90388. The number whose logarithm. Now they have given you the logarithm. So they have given you these values down. They want the number. So, but you need to first check where this value lies. 90 whose logarithm is, it was, I have wrongly set this, it is 90, it is 1.90388. So you can easily check where it lies. 903, 90, this is 903, this is 9031, 9038. So it is in between these ones here. 90388 is in between here, meaning that we shall use this and this, this and this, then this one is in the middle. Okay, so we shall extract for part 2. I'll just extract for you and then you continue. So we shall extract a table of x and log 10 of x. So you're going to have 80.00, and here you're going to have 1.9031. Then here you're going to have the number you're looking for, because you're looking for the value of x, but it is corresponding to 1.90388. Then this will be 80.20, corresponding to 1.9042. So you can solve for the value of x. Now, these things they put, logarithm, what? They are the things that make students fear these numbers, yet you can easily do with a lot of ease. So that is a number to be concluded by you, a student, by you as a student. To all viewers, here is an exercise. Number 1, in the table below is part of an extract from sec . So it is written like that. So we are having x is equals to 16. Then here we shall have sec x. This one stands for a minute, but here there is nothing you need to convert. You just need to be smart in what you're doing. So the first value is 0. Here it is corresponding to 2.40. Then you've gotten 12, it's corresponding to 2.0122. We are having 24, corresponding to 2.0245. Then we are having 36, corresponding to 2.0371. Then we are having 48, corresponding to 2.0498. Use linear interpolation. Use linear interpolation. Estimate value of sec 60 degrees, 15, then 2 angle whose second is 2.0436. Those ones who do Ugandan examinations, this was in UNEB of 2005, paper 2, question 2. Okay, so now here, as a hint, don't look at a 60-degree word. For you, look at where this second is lying. So if you have 15, it means that 15 is between 12 and 24. So you're going to extract that, all right? And then you see what to do, okay? If you're having 2.0436, you're going to look at where it lies. 2.043 is 0.043. So 0.043, that is like here. So you pick this and you work out. When you get like 24 minus 12, you'll keep with 12 and you continue like that. So that is what you're going to do as you exercise. Let me add you one more question so that you can practice better. For your practice reasons, I'm looking for another question that can easily be done by you people. Here is another question. And this question is saying, the table below shows distance in kilometers a truck can run with a given amount of fuel in liters. Okay, so we have distance, and then distance in kilometers, and then we've got fuel in liters. So we are having 20 kilometers, 10 liters of fuel, 28 kilometers, 13 liters of fuel, 33 kilometers, 21 liters of fuel, 42 kilometers, then 24 liters of fuel. Now, estimate how far the truck can move, how far the truck can move on 27.5 liters of fuel to the amount of fuel, estimate the amount of fuel required to cover 29.8 kilometers. Let me see if you'll get 15.88 liters and if you get 52.5 kilometers. I wish you all the best. You're going to link in another topic called errors, where we are going to discuss much of this. So you're going to discuss much of the errors or numbers about errors, and then we'll keep moving up with our numerical methods. I wish you all the best. See you there.